When software developers and programmers go out and actually build the code for applications and software, they use organizing code in logical flow best practices in order to keep things structured. So, organizing code in logic flow, there are two simple ways that we can keep things organized. By keeping our code organized and making sure that it flows logically and that everything's well structured, that everything's well formatted and properly built, it makes things easy for anyone who's viewing it to understand the code and the code's purpose, to add to the code, to troubleshoot the code, to fix the code, and also in certain situations, it also makes it possible for the code to actually run. So here's some ways that we organize code in software development and programming. We can use indentations, we can use modular code, we can use comments, we can use flowcharts as well, and we can use sequence to decision to repetition diagrams. So let's first start here with indentation. And if you've ever seen code, you've seen this. Indentation is the spacing and the tabs that programmers use to group various lines of code together. It essentially shows the body of functions, loops, conditionals, and other types of statements. So here you can see in this code, on line 3, we have an indent. On line 5, we have an indent. On line 7, we have an indent. On line 10, on line 14, and on line 19. And the reason why we have them is because this is what's sort of separating these two or these 3 lines of code from the code below it. So we know that this is referencing if dice equals 6, then we print win. Else if dice equals 1, we print loose, or should be lose actually, but I didn't make this code. This is just an example. And from there, we have else print roll again. So you can see that indentation helps us really understand the logic, because if this was moved over, this would read like if dice equals 6, print win. And you would be like, okay, is that part of if dice equals 6? So all that to say, that's what indentation does in our code. It makes it more simple for us to read it as humans, and it also makes it easier for us to just come in here, look at things, see the logical flow of things, and overall, it keeps things relatively simple for us as people. Modular code helps us break a program into separate parts, and then each part is able to handle one specific task. So in this case, let's just use a print module as an example. In a printer, we have a software interface. So when we go to actually do a print job, we go on our, let's say, a PDF from our computer, we print that out, and then the module or the software handles it and then actually interacts with the physical printer. So that's what this intermediary model does. As you could see, even if we have multiple different print jobs or multiple different areas that need to be handled, we can break this print module into each of these areas, and we can also have the module act as just one thing. So in this case, what could happen is if we need multiple things to be updated, like let's say that there's a bug with each of these, we could just update the print module. Same thing. It also helps us because we still have control over each individual area or each individual part. So essentially, all modular code is it's taking one big thing and splitting it into smaller little things. That's the whole idea behind modular code. It's taking a huge concept or a huge program or a huge software or a huge function in a program and then breaking it up into different pieces of code. Next up is comments. And comments are very, very simple. Essentially, they're notes in code that are ignored by the computer when a software is ran and only really meant for humans. So for example, in certain programming and scripting languages, you can put this symbol here in your code, and then the computer will actually ignore anything that comes after that on that specific line. Again, it's just useful for software developers who want to put a quick note in there, and no one is able to actually view it when the program's ran. So if you don't have access to the code, nothing's going to happen. You won't see the comment. But if you're a developer or software designer, whatever, and you have access to the code, then you can go line by line and actually see the comments and see what people are putting in there. Now, not everyone uses comments, but for the most part, if you're working with code where multiple people are going to be touching it, you have to have comments to explain certain ways of thinking and certain types of things that shouldn't be modified or shouldn't be touched or should be touched. Comments really allow you to explain anything that you're needing to put in there. It's sort of like a commenting system on Google Docs. You're able to comment in certain areas, and it doesn't really affect the document. It's just for people who are actually reading the side and people who need to actually modify the document to see. That's really what comments are. They're just notes in code, essentially. Next up is flowcharts, and flowcharts are diagrammed step-by-step flows of a program. We've already covered flowcharts quite a bit in the previous video. We went through different types of conditional statements as well as different types of loops. So you don't really need to understand these, but essentially flowcharts, they're just diagrams that we can use to build things out logically before we actually start to implement them in code. Next up is the 3 parts of programming logic. So we have sequence, decision, and repetition. And these are sort of the building blocks of our programming logic to determine the order that code is executed in. This is important because if you build code the right way, but it's in the wrong order, even if the code is technically right, if it's in the wrong order, the wrong sequencing, sequencing, it's not going to run as intended or as effectively. So in terms of sequencing, things can be done step by step, straight down. If things are built line by line, it could be done like that, or it could be done by decision based, like this, with a diagram, sort of like this. But in the code, it's not really actual diagram. It's just this is the way that we as humans would interpret this if we were actually thinking about it logically. Same thing with repetition or loops. We've already talked about those quite a bit. Just keep in mind, these are just different ways of really building out the way that the computer addresses and then goes through code. So these are just 3 different methods for that. And in this video, we talked all about organizing code as well as using logical flow when we're implementing and when we're building code. You don't need to, again, understand these from an in-depth level or in-depth perspective. Just understand what each concept actually is, and you'll be able to apply this to the Tech Plus exam.